Welcome to the Now and Then podcast. I'm your host, Dan McCool. Join us as we dive into the fascinating journeys of professionals across the globe who have dedicated 15 or more years to their careers. Come along as we explore how their roles have evolved, the challenges they've faced, and the wisdom they've gained along the way. I can't wait for you to hear their insights. Let's uncover the stories behind the experiences of these remarkable professionals. Welcome to the Now and Then podcast. Hi, y'all. I'd like to welcome everybody to the Now and Then podcast. Today, my guest is John Bartholomew. He's a nuclear power plant operator. He actually ran the only remaining nuclear power plant in the state of Washington for many years. He has retired now and is enjoying his retirement, camping out in his lovely Airstream trailer and hitting a lot of bluegrass festivals. So welcome to the podcast, John.
Thanks a lot, Dan.
We'll go ahead and get started here. The first question is if you could just tell us a little bit about your background, what led you to become a nuclear power plant operator? Was there an aha moment when you knew you were meant to be in the nuclear field?
Okay, well, this is a long story that I'll try to shorten up a little. I grew up in one of the several nuclear towns, atomic cities in the United States, Los Alamos, New Mexico. I was just down the hill in White Rock. My father was a nuclear engineer. He started as mechanical, got his PhD in nuclear. So looking back, I would say I was probably doomed for life in nuclear. I was 17 years old, graduating from high school, had no idea what I wanted to do with the rest of my life. And I knew that had I gone straight to college, for me personally, it probably would have been a waste of my father's money and my time. So I joined the Navy. I was always interested in electronics. I took some electronics and electrical technology electives in high school. So I talked to recruiters. The Navy recruiter said, yeah, I like electronics. He says, well, I got a deal for you. Wanted me to... in the nuclear field, there were, at that time, this was in 1981, U.S. Navy nuclear field, there were three main rates for enlisted people. Electricians mates, electronic technicians, and machinist mates, and I wanted to be an electronic technician. What I didn't know at the time was that for the recruiters, if they could get a guy, or at that time it was only men. Now I think it's great that women can also participate in the nuclear field in the U.S. Navy. At that time, that wasn't the case. But if they could get a recruit to qualify for the nuclear field, that was a double quota for them. So the recruiters had a lot of incentive to try to get people to sign up as nukes, as they called us.
Mm-hmm.
So you go through some tests, and I passed the test. They said, yeah, you could be a nuke. So I thought, okay, that's what I'll do. Well, the training is about 2 years. It's a 6-year obligation, and 2 years of that, at least, is just training. So I went through like a basic electronic school, an electronic technician A school, classroom training for nuclear propulsion, and then hands-on prototype training. And this was in Idaho Falls at the S-1W prototype plant. That was the plant for the Nautilus, the first nuclear submarine.
Yeah.
So that's how I got into nuclear. And I was pretty good at it. It was very demanding, very challenging. And I felt at the end of my time in the active duty Navy, almost 9 years, I thought, boy, I need to do something different. So I went to college to become a mechanical engineer. And I didn't want to be involved in nuclear anymore. Anyway, I ended up, when I finished school, the only offers that were coming through were out here in Richland. And I was working at as a subcontractor for the Hanford site for the Department of Energy, doing nuclear-related work, not nuclear power. And eventually, through the, sorry.
We'll edit that part out. Don't worry, man. Okay, go back to eventually.
So eventually, the Department of Energy related work was just not working out for me. And a friend of mine told me, hey, the power plant at that time, it was Washington Public Power Supply System, WNP2, is hiring engineers. So I thought, okay, great. Well, maybe I'll do that. I still want to make money. So that's what got me into nuclear, back into nuclear, commercial nuclear power.
Mm-hmm.
And after a time there, about 9 years as an engineer, I saw that the life of an operator was a lot better than the life of an engineer. You got paid for every hour you worked. And if there was ever a time when you when they might be laying off, for example, the saying was always hug the reactor, get back to the plant. And so as a licensed operator, that's a very valuable position. All the positions at the plant are necessary. It takes more than just operators. But again, you're talking 2 years of class to study and test and eventually obtain a license from the NRC. So I did that, and in 2009, I received my senior reactor operator license from the NRC, and I became a nuclear plant operator at the plant. And it was a time, in retrospect, it wasn't what I intended to do, but looking back now after 26 years, it's been a great career.
Mm-hmm. Yeah, I love that. I love that phrase, hug the reactor.
Yeah.
Yeah, in most instances, you'd think you want to run away from the reactor, but when it comes to layoffs and stuff, probably not, huh?
That's right.
That's funny. I love that. So you worked out there for over 20 years, huh? Wow, that's
Right.
amazing.
And the majority of that in the control room as a senior reactor operator.
Right. That's good to hear that they require so much training, because I know that the DOE is a big time out there, and it's safety is a major concern. You don't want to have somebody unqualified out there messing around with that stuff at all. Yeah.
Yeah.
So
and there's a continuing process of training when you work in the control room on a crew. 1 week out of every 6 is devoted to training, where you run casualty drills. We have I say we. That's one thing I'll probably do a lot out here is say we. I am retired from the plant, so I'm no longer part of Energy Northwest, actively working, but I still think of it as my plant. So
sure.
But I'm not working there still. Anyhow, continuous training, continuous drilling, and striving for continuous improvement.
Right. Well, that's really good to know. So, obviously, you're pretty deeply involved in that whole culture. So how did you see that culture changing over the years as you worked? How did it evolve?
Well, one thing that's true in the Navy nuclear propulsion as well as commercial nuclear power, the fundamental thing has always been absolute integrity. You have got to be completely honest, completely forthcoming. Things do go wrong sometimes. We have a big enough team that you have a backup. If one person makes a mistake, someone else will probably catch it before it becomes a problem. But you got to be willing to own up to those errors and mistakes. So that's always been a big part of the culture. It has changed even more towards safety, and if things take longer, that's okay. There was a time where production was the key thing. We want to get this plant started up. We want to run. We want to do whatever we can to reliably and safely provide power for the region. And that's always been the case. But now the culture has changed more and more towards it absolutely has got to be safe. It has to be right. We'll take whatever time it takes to make it right. There's a saying in the U.S. Nuclear industry that we're all hostages of each other. We're only as good as the worst. Every time there's any kind of accident or near miss, it reflects on all of us. And so possibly unlike other industries, we share a lot of information with each other. We share our operating experience and lessons that we learn. So the big change probably has been more towards even more sharing, being more self-critical, do things right the first time rather than try to get it done quick.
Wow, that again is really good to hear, because in the past, obviously, there were some issues with nuclear. They had some problems there at 3 Mile Island and some other places. Although I guess they're going to restart 3 Mile Island. Apparently, Bill Gates wants all the power.
That's right. That's an interesting development. There have been several, some plants, like the Bellefonte plant in TVA, that was never actually started up. It was sort of mothballed, kind of like the other four plants that Washington Public Power Supply System, now Energy Northwest, started back in the 70s. So
Mhm.
we're looking at finishing idle plants that weren't started up, restarting plants that have been shut down, and license extension. That's a huge thing. The plant that I work at, Columbia Generating Station, original license was completed last year, the original 40-year operating license. But prior to that expiration, we went through a process of license extension to get another 20 years. And I understand the staff out there is working on an additional 20-year extension. And other plants are doing the same thing.
Wow. Okay. Yeah, I hadn't heard about any talk about starting up or the plants out there at Hanford again, but so that's interesting to consider.
Well, I don't know that that's going to happen. There was a time when that was being considered. To my knowledge, there is no one currently discussing restarting the four plants that were not completed, or
Yeah.
completing and then starting those plants.
Right. Okay. Well, okay, that's good to know too, because you hear all sorts of rumors about all sorts of things out there, and it's good to get hear stuff much closer to the source. So thanks for that, John. My next question is again about change. What technological advancements or new techniques have had the most significant impact on your daily work as a power plant operator, nuclear power plant operator?
Well, obviously, nuclear power is technically it's highly technical. We have thousands of systems, tens of thousands of components that all have to be maintained, serviced, replaced at specified intervals. But as far as embracing new technology, that's rare because the qualification process for equipment, again, you have a quality class one requirements for anything that's what we call safety related, and that's any component or system that's necessary to achieve and maintain safe shutdown of the reactor. So those components are rigorously designed and tested, and they're not modified or updated very often, and if they are, it's a very lengthy process. So, however, that being said, some things that have been huge improvements um, is when we've gone to some digital controls. We used to have electro, hydraulic, mechanical controls for our reactor feed pumps. Those take the water from the condenser, feed it into the reactor at over 1,000 psi. And as power
Wow.
changes, you need to raise the speed of the feed pumps. If power goes down, they need to lower. And those are typically in automatic control. The old systems we had, electro hydraulic, had issues because they were so mechanical, they would wear fast and components wouldn't work. Back in 2009, we put in a new digital feed water control system, and that has worked, I would say, nearly flawlessly since implementation. And that was something that I think that the plant should be proud of because it was designed and implemented by our own engineers. Our own staff designed that system and worked with operations and maintenance to install it. A similar type of control system went in for the main turbine throttle and governor controls, because that's how you get the steam to the turbine to spin it around to make the power for the people. And again, that had been an older type of system, and that was upgraded. A big thing that's coming in our next refueling outage, I say "are," I'm not going to work there, but maybe. I never say never. Anyhow, the next refueling outage for Columbia will implement a new reactor recirculation pump drive system. Now, the reactor recirculation pumps take water. The feed water comes into the reactor, and it's fed through a jet pump, and the jet pump gets its driving force from the recirculation pumps. And so those systems directly affect reactor power, reactivity as we call it. And so they're a variable speed from like 15 hertz all the way up to a little over 60 hertz. And the frequency they operate at is directly proportional to the reactor power. You raise power by raising the speed of those pumps. And the system that we had is a good system, but it's old. It's wearing out. And so, again, our engineers and some other industry experts are working on a brand new design that's going to be implemented in the next refueling outage. And all of these, one common part of all the new systems we put in is a coincidence feature. There's typically 3 control channels that work together to send signals to the system. And 2 out of 3 have to agree all the time. And if one of them fails, you still have 2 systems. So it helps to remove what we call single point failures, where one component fails in a non-coincidence type of system, or one component fails, it could cause the plant to trip, it could cause a problem. So it's a way to build in more reliability. So the biggest in the technical advancements are probably going digital and putting in better reliability for the systems.
Yeah, more redundancy. That sounds like a good idea. And one question I have about these improvements, I know we have really smart guys out there in Hanford and all over the area here. Those improvements that they developed, did they have to get those approved by the NRC, or is that sort of an in-house thing that you can just have some latitude?
There is a process. It's virtually everything that happens in a nuclear power plant is guided by the Code of Federal Regulations, CFR.
Okay.
And 10 CFR 5059 is the process by which changes are made in procedures and systems and operating methods at a power plant. And so there's a rigorous screening that you go through. Not every change is going to require NRC permission. So the process of the 5059 is to see if NRC permission is required.
Okay.
Certainly anything that could affect the reactivity of the plant, that is something that the NRC will review and will look at. Other things like license extension, definitely, if it has the potential to cause a different kind of accident than what has previously been analyzed for, or if it could make the consequences of that accident worse, then that's the type of thing that the NRC has to give approval for.
Mm-hmm. Yeah, well, that sounds like a good idea. Okay, so can you share a memorable story or an experience from your early years that might contrast with how things are now?
Oh, well, it's all been pretty memorable in a way. One thing is the industry is always moving forward. We have the Nuclear Regulatory Commission, the NRC, which is the inspection and essentially enforcement arm of the Code of Federal Regulations for the operation of a nuclear plant. Mm-hmm. They grant licenses both to individual operators as well as the licenses for the plant itself. And there's also a organization that's made up of the individual plants. It was the Institute of Nuclear Power Operators. That was created after the 3 Mile Island accident in the 70s. That was one of the recommendations of the report to Congress. And so that trade organization doesn't necessarily have enforcement power, but they do they do evaluate plants, see how they're operating, and the NRC listens to what INPO has to say. I would say, without trying to be too accusatory, because we all learn and grow as time goes by, there was a time when the industry focused on production, possibly more than they do now. There was a goal of short refueling outages. Right, our plant refuels every 2 years, so it's pretty neat to think here you've got a nuclear power plant that it only needs to shut down once every 2 years to perform the maintenance. There's certain maintenance like refueling the reactor and working on the steam plant that can only be done when it's shut down. And the goal was to make those refueling outages as short as possible. There were plants that were achieving a complete refueling outage in something like 15 days, about, say, 10, 15 years ago. The plants are no longer chasing that short outage like they had been. It's more focused towards let's get all the work done scope the work correctly, make sure we're doing the right work, make sure we're doing that work right, and make sure that we can start back up and run reliably and safely for that interim 2 years before we shut down again. That's the goal. It's not always achieved. Unexpected things happen. You have unit trips, and you have to react to equipment errors. But that's so. Again, the focus even more. It's always been focused on safety, but an even greater focus on safety and a willingness to sacrifice some production for safety.
Mm-hmm. Right. Well, that's good to hear too. And that's kind of what I hear in general from people that work out there, that it has become more safety oriented and a little bit less production. The turnaround every year not every year, every 2 years is a big deal out there, and people come from all over the darn country to work that turnaround. So
That's right.
yeah, and it's no sense rushing through that sort of stuff. So you had a long and productive career out there. And during that time, how did your personal goals and motivations shift?
Well, as I said, I started as an engineer, and my original goal, honestly, was I'd like to have a job. I'd like to stay.
Yeah.
I'd like to stay in Richland. I
Mm-hmm.
briefly worked at the DOE site in Rocky Flats because the company I was working at when I first came to Richland um, was basically our work at Hanford had kind of dried up when a new contractor came in. These are the days before being in the power plant. And so I worked at other places, and I really wanted to come back to Richland. And so I did, and working at the plant allowed me to do that. Then, of course, trying to learn my systems as an engineer, that was a big motivation to try to make those systems as reliable as I could, learn about them, make sure we do the right work on them. Then, again, I shifted to wanting to become an operator and get my license. And that was a goal. And it's not an easy thing to do. Just like in the Navy, there is some attrition rate. Not everybody that enters the program comes through on the other end. The great thing I have seen with Energy Northwest was if a person doesn't make it through their licensing program, there's still a place for them. There's still valuable work that they can do. So my goal, of course, was to make it through the class, to get my license, and then the job is to operate safely every shift. It's a 12-hour shift. We work days and nights and holidays and weekends and all that. So the goal was to make sure that the people stay safe, the plant stays safe, and we operate. Again, that's something that everybody still does today. For me personally, I had a goal of becoming a shift manager. And the shift manager is the person who is in charge of the operating crew. And on nights, weekends, holidays, the shift manager is the senior person on site, responsible for the operation of the plant, the safety of all the people there, the physical security of the plant, calling out people if we have a snowfall and we need to,
Mm-hmm.
clear the lots and the roads on the plant property. Anyway, that was a goal which I was able to achieve, and the thing about that, I did achieve it, but I've never achieved anything in my life completely on my own. You got a team of people that help you. And that's the valuable thing, again, that I learned in nuclear, that you're not on your own. You got people to help, and we all want to succeed. As I saw my career coming to an end, I had a goal of retiring early this year, which I did. But I didn't want to go from being that senior person responsible for all operation, kind of a big deal position, to the next day just being another grouchy old fart at Starbucks, right? So I intentionally kind of wound down my career. In the last 2 years, I work in what we call production, where the maintenance of the plant, every work order that we perform on all those thousands of components, all the maintenance, the planned maintenance or corrective maintenance, it all has to be evaluated for the impact on the plant. Can it be done with the plant in the current mode, whether it's online or shut down? Can it be done with the other work that's already planned for the same time period? You have to look at the impact. And that's more of an individual contributor, something I would do by myself, as opposed to being on a crew. So I went to that position about about 2 years, and it was a good move for me because I transitioned from being in a position of authority and responsibility to a position of less authority and a different kind of responsibility.
Okay.
Of
Well,
course,
go
I'm just
ahead.
going to add that I don't never want to burn bridges, and so I always wanted to leave things, and I feel I did, that should
Mm-hmm.
I choose to come back for some reason, or should they need me and I feel like, yes, I'm willing to do it, I'll be able, you know, I wanted to be able to do that. And I think I've achieved that too.
Well, good. It sounds like you've made a thoughtful transition, and you knew where you wanted to go and how to get there. So that's a great thing. You know, whenever I hear about burning bridges, there was a person who told me, "Yeah, the only bridge I want to burn is the one behind me, lighting the way forward." so so every now and then you might want to burn a bridge, but I just wanted to make that comment there.
That's a I had not heard that before. That's an interesting thought.
Yeah, yeah. It won't work in every circumstance, but every now and then, you know. Well, that's the end of part one of my interview with John Bartholomew. Thanks for listening. We'll be hosting part two of the interview next week. Stay curious. Carpe diem.